Hello everyone. Good evening, and thank you very much for joining this session. I know it's very late in the evening, and probably I'm the person keeping you away going from here. So we'll try to be as short as possible. Like I might be taking around 30 to 40 minutes, the usual regular time, but essentially that's what it will be like. And if you have any questions, maybe we'll keep it at the end, and if you are not able to put some time for that, probably I'll be around and you can ask, you can come to me anytime. So this session is basically a explanation or a deep dive into what a practitioner can do with Databricks Serverless. And when I say serverless, this session will be more talking about serverless workflows in general, which is where you orchestrate all your jobs, pipelines, notebooks, etc., a lot of things like Power BI also very recently. So this session is more about workflows and what you can do in workflows, and more so what you can do with Databricks Serverless, essentially. So that's a high-level overview of what this session is about, and very brief intro about me. I'm Prashanth Babu. I'm a product specialist based out of EMEA, London, to be very precise. And I've been with Databricks for the past 7 years now. And my main role is about on serverless. I'm a product specialist on serverless workflows, to be very precise. So for a change, I do not have any slides. This is the only slide I have for today. So what I will be doing is I will be opening up the platform, Databricks platform, to showcase what you can do in Databricks platform with Databricks Serverless workflows. And also I will run through a brief overview on what you can do in serverless notebooks also, and then transition to serverless workflows in a seamless manner. So as I said, this is my only slide for today. So now this is Databricks environment, and this is what you see when you launch Databricks platform and probably create a notebook. So let me start creating a simple notebook, or in fact, we can take this simple notebook itself. Now this is a notebook which has a lot of cells, and I'm not doing anything crazy here. I'm just simply listing a particular location. This is available in any and every workspace, directly coming from Databricks datasets. And I read that datasets, the data which is there in that folder in the Perker format, and then write it in Delta format, and then just display it. That's what I'm doing in this notebook. I mean, this is the end of it, so there is a limit. So this is a simple notebook, and I have a companion notebook for this, where I do some reporting and filtering. So we'll start with this first. So as I said, this notebook doesn't do anything too much. So I run through a couple of steps and then move forward with, this is basically ingestion, if you see it from that angle. The next one is for reporting and filtering. Now, if you are in the erstwhile classic workflows, so let me go create a simple cluster. So this is how you go create a cluster, create compute, and then you have to select a whole list of things here, like right from compute name to, more importantly, the DBR version, and if you require Photon or not, and also the worker node type and driver node type. I mean, driver node type is auto, which picks it up from worker node, and a lot of other things like even more advanced, where you might have to specify what mode do you want. Like usually it is always standard mode. In this case, I'm choosing standard mode, which was recently renamed to standard mode. It was previously called shared security access mode. So these are the things we need to do for creating a simple cluster. Now, we create a cluster, and we might have to wait for, depending on the instance type and the number of instances and the cloud provider, probably you're looking at waiting around 3 to 7 minutes approximately. So that's what it will take for creating a new compute. Now that's in the classic world. Now, if I go to the serverless world, right now I'm connected to a serverless. Probably I will just terminate this. Now the only thing you can see here is it is simple notebook, and it's not connected to any cluster right now at the moment. Now you have two options. One, choose serverless, or two, you can create your own resource. So in this case, I will choose serverless. Now look at the, I mean, you might have gotten used to classic classic clusters. So that's where, if you see how seamlessly and how easily you can create a serverless cluster, and you can connect to serverless cluster in how much time, that's what is the magic here. Like when I click on connect, now you can see it is already starting. That's because the VMs are coming from the worm pool. We are not going all the way to the cloud provider and getting the VMs provisioned by the cloud provider. Now if you see, I'm already connected, and I can start coding with my development. So that's so easily we are moving ahead, and we can also continue with everything. Like you can see, my code already is running. So in this case, I will just do clear everything so that I can show that it is really running right now. And I will do a run all in this case. So let me do a run all below, yeah. So let it run. So it will start immediately. As I said, okay, there is one cell which is already running. So this is how fast it will be. Like if you are used to classic, this is a completely different paradigm, and it is much, much more efficient because you're not waiting for the compute, and you're not selecting 1,000 odd things. Like if I go to if you have attended Roland session just now, it finished in the other room. So this is what it was before. On the left-hand pane, on the left-hand side is what you have to select in a classic cluster environment. There are a whole lot of things, as I mentioned, like DPI version, photon on or off, or instance type, driver node, worker node instance type, and access mode, and so on and so forth. Now in the classic world, there is nothing. By default, it is compute of serverless. So that's the only thing you need to do. And I'm talking about notebooks here. So there is, as an extension, we can transition this pipeline directly to workflows also. So let me take one more step here to showcase what exactly we have in serverless. So in the right pane, you can see a couple of options here. What I'm interested in is in environments. This is a new concept in serverless. So this is only available in serverless. If you see why it is, I will be explaining now. So there is this accelerator, which is more for if you are interested in some GPU processing, GPU required processing, probably you will choose A10. In my case, I do not need GPU, so I'm not choosing. And then there is memory. I mean, the way serverless works, it works on the concept of Spark Connect. So it's not the same old classic Spark architecture where there is a driver and there are executor nodes. So now in the new world, it is Spark Connect will be the default between what you execute and what is there in the driver and executor. So it's a completely different paradigm now. So that is the reason the concept is different, to say so. And assuming that you have pure Python workload, for example, you're doing a lot of pandas-related processing. In that case, probably, in the classic world, you would have started a cluster, say, assume 5 to 10 nodes, 5 as the minimum and 10 as the maximum worker nodes. In that case, you would be provisioning the entire cluster, like 5 to 10 worker nodes for that particular job, which doesn't need that cluster at all because it's all running on pandas. Now, in the serverless world, we will not create a driver and worker node at the entire cluster until unless you run a Spark command. So if assuming, in this example, I do have a lot of Spark code, but if it was the case that I didn't have anything Spark, but it was only pure pandas, we will not even create the cluster. And by default, we specify the standard memory as 16 GB. So the REPL, which is executing this code through Spark Connect, is having a memory of 16 GB. But if it is pandas, obviously people will do .2 pandas, .collect or whatever. It's going to be huge. So in all those cases, probably you might want to choose high memory, which is 32 GB. So that's about memory. And there is a new concept of budget policies. If you are used to classic world, you might have seen cluster policies where you can specify mandate, the specific DBR to be used, photon on or off, number of VMs, etc., instance type, and a whole lot of things which are possible in cluster policies. So that's about classic world. Now, if you move to serverless world, logically there are no clusters because clusters are running, it's more on cores rather than clusters in serverless world. So you will not see any clusters. The only thing you will see here is a simple one. Here it is. That's the only thing you can see. There is no cluster ID. There is nothing you can see here. So for that, we have a new concept called budget policies. Now, budget policies are pretty simple. Now, if I go to my settings and go to compute, and then I should jump to budget policies. So this is where you create budget policies. Now, in this case, I created a budget policy called budget policies demo. I can specify tags, so which is what you see in the UI also. So I created a budget policy demo, and I created a project tag and its value of data engineering. So this is how a budget policy is created. I mean, I can edit it right now, saying probably demo at dice, and I will save it. So this is how I created a simple budget policy with a tag. Now, if I go to my notebook, I can see what budget policy. So let me refresh this because I created the budget policy just now. I should be able to see what budget policy I have, and also what budget policy tags I might have. I might be getting. So you can see here, I do have. I did get the demo of DICE also as budget policy tag here. Now, the importance of this is that this is useful for attribution, like how many DBUs a particular user or a particular group of users have consumed. All that information could be easily available in system tables. I will run through that simple query also and show that. So essentially, this is how you run budget policies, run notebooks with a budget policy. The other thing to note here is I can have like 5 or 10 budget policies assigned to me. And at that point, I can select whichever budget policy is applicable to me for that particular workload and run this workload. So, and again, please note that you can have any number of budget policies, and you might have to choose which one is most adaptable for you. Or there is a probability of choosing default budget policy as well for serverless workloads. And now the concept of base environment. Now, in the classic world, there used to be init scripts where you specify the jar files, the environment variables, and a whole lot of things. Coming back to serverless, again, in serverless, there are no clusters, so there should be an intelligent way to do this. That intelligent way is environment, and I can specify the environments here, like whatever version. For example, in the case of classic, you'd be upgrading the DBRs constantly. Like if you attended the session with Roland, he did talk about one specific thing on serverless. Yeah, this is the slide I was looking for. He talked about versionless, where a lot of our customers are running a lot of, are spending a lot of their time in manually upgrading DBRs, and up to 20% of their time is spent only on upgrading. So I mean, the SMEs, highly knowledgeable, skilled Spark developers and machine learning engineers, instead of spending time on productionizing their use cases, they rather are spending their time in upgrading DBRs from 14.x to 15.x to 16.x, pretty soon 17.x. So that's a pain, and most of our customers said they are spending up to 20% of time. And also, it's usually months behind latest performance. So if we move to serverless here, in the last 1 year and 1.5 years, to be very precise, we have done 18 DBR upgrades. And in that, we moved from 14.x step by step to right now at 16.4. So a number of workloads which you upgraded as part of this 1.5 years is 1.3 billion workloads. Like each workload, each notebook, each job. You see how many of our jobs we have right now. There's the total we have upgraded is 1.3 billion. And the other thing to note here is the success rate. The way Versionless works, I mean, there is a wonderful talk by Justin Priest tomorrow on serverless, how Versionless ensures serverless. Please take a look at that session. Please join that session if possible. He's going to go into the weeds of how serverless is versionless. And also, there is one important key point here. Though we had done 1.3 billion workload upgrades, the overall success rate is almost 100%. It's just 0.002 is where we failed. and there is better performance. Now, I said a lot of things there. So to show what exactly it is, let me open what is the release notes. Now, this is the release notes. You can see 14.3 all the way to 16.4. So these many versions we upgraded in the last 1.5 years. And I was talking about versionless and environments. Now, my dependency, for whatever reason, I have dependency on Python 3.10, for example. In that case, I would use environment version 1. Now, if I click on system environments, you can see it is 3.10. So you choose environment version based on your requirements. It doesn't need to be that Databricks is mandating DBR upgrade, so you are being pushed to upgrade DBRs. That's not the case anymore. It's more like you are choosing your own environment version because you need something very specific. Now, if I go to version 2, the Python version is different. It is 3.11. So that's the difference. Like, you upgrade your environment version based on your requirements. If for whatever reason you have a library which depends on Python 3.10, you'd be using environment version 1. If it is version 2, you move to version 2. So going back again, so this is how you define versions here. Now, there are multiple ways of installing libraries. You can do with pip install, %pip install. That works the same way in serverless as well. But the better and the most important and efficient way of doing it is creating dependencies right in this notebook here. Like, let me install, say, a faker here. And the only thing I need to do is this apply, implies whatever I changed here, they will all apply. And the library is getting installed right now in this cluster right now in the serverless environment. The moment it is installed, it's available for me for use to use in this notebook, and also when I upgrade, when I push this pipeline to workflow, even there it's available. So this is all about how you can use environment. So this is the very important concept in the entire serverless versionless. Now, if I go back to again slides from Roland, there is a section which talks about this. So this is what I was talking about, the REPL VM. So in the traditional classic Spark architecture, which is on the left-hand side of this slide, everything is running in the driver node, like your Python code, your Python version, all the libraries which are installed, everything is running in the driver. So driver becomes a bottleneck, and the executors also are there. So in that case, to upgrade the DBRs, you'd have to manually update your application code and also any Python libraries which are bundled in that particular DBR. So you need to take care of all that. Now, if you move to serverless, the clear cut, the difference here is you can see there is a REPL VM which is running standalone, and it connects to the driver and executors through Spark Connect. Now, that's where the difference comes here. So because the way the Python libraries are running in a REPL VM and not on the cluster, so it makes it easy for us, for Databricks, to upgrade the DBR seamlessly. So that's how we have been doing a 1.3 billion workload upgrades. So that's a lot about what we have been discussing. Now, I did install Faker. So Faker is already available. Now, to show it is really available, I will just download this IPython notebook. I mean, this is the IPython version, so I will download this, and let me open the IPython notebook. Yeah. So here is where I started my, you can see my dependency is already available in IPython notebook. So the moment we transition this notebook to workflows, it's available again there in the workflow. So to show that all that, I will just move to create a schedule for this. I just ran a notebook for this, a job for this, but I will just show probably live demo of serverless. So it's already choosing serverless. There is a subtle difference the way you run a notebook in serverless workflows. The difference being there is a performance mode, which is called as performance mode, implies I want to run my job now. So that's where you choose performance optimized. Now this tooltip talks about it. Performance optimized implies it will run as fast as possible and immediately. And there is another mode called standard mode, which has a startup delay of approximately 5 to 6 minutes. And after that, the job starts. And it is cost beneficial to run it in standard mode. I mean, depending on your use case, you might choose performance optimized mode or standard mode. Now in this case, I will just choose performance optimized mode. And then I will go to the job. So if you have already used serverless, you might be familiar with this. So essentially, I have chosen performance optimized mode here. Let me go to the task tab. And I have the normal ingestion task. And then I will be creating another task by name probably filtering or something like that. Filtering. And choose the notebook. So I'm done. So this is same way as what you've been doing with classic workflows as well. Now when I click on create task, and because this is performance optimized mode, the job should run immediately. Let me start the run. The run will start immediately within around 30 seconds. The job should start. Let's let it run. So meanwhile, I will showcase what I've done today afternoon. So I had a job which was running. Let me go to the job. So this is a job. I ran this job multiple times earlier today. So you can see I ran with parameters where you can see serverless, compute parameter as serverless and mode as standard. And the other one is compute as serverless and mode as performance optimized. And the third option being compute as classic, and there is no mode in classic, so it's normal. So you see the duration of each of these jobs. It's exactly the same job. The only difference being the way it is triggered. When I say the way it is triggered, I meant is it performance optimized or is it standard mode, or is it serverless or non-serverless, I mean classic. So that's the only difference. Now you see the difference. Standard mode is approximately exactly the same time. The duration of the job is exactly the same time as classic. So that's the difference. Though we are running in serverless, we are being cost efficient, and at the same time, the job is taking exactly the same time. Now, performance optimized, as I said, the job starts immediately and will try to run within no time. And there are some limits, but still, it is much better, much faster option. I did a comparative analysis as well of these runs. Again, if you go to if you have access to system tables, there is a whole page of information about system tables. Let me go to the most important billing.usage. So this is the table which has all the information of which user has used, what workflow has caused, how many DBUs, and a whole lot of information. Now, I'm showing here a bit of information by joining two tables. One, system.billing.usage, here it is, and the other being job run timeline. So by joining these two tables, I get a view of the number of DBUs of a particular job and also the elapsed time of that particular job. Now, here it is, the same jobs which we were discussing just now. Performance optimized, it's approximately 181 seconds, and the number of DBUs is 0.5, for example. And standard mode is almost the same. I mean, if you see the elapsed time, it's almost the same as classic, 527 to 531. And the number of DBUs. Now, the difference here is, in the classic world, you would get a bill from Databricks as well as your cloud provider. In the case of serverless, you'll get one single bill that's from Databricks. Now, I mean, just try to imagine what exactly we are seeing here. Now, the DBUs here is the whole bill, like whatever is your rate on the cloud provider and also the region which you're running in. If you multiply the value of Databricks Serverless there, that will be your overall cost. And in the case of Classic, probably you might have to multiply this with the region's value, I mean DBU value, and then add the cloud provider cost also into this. That's how the total cost will be coming to you. So essentially, I'm just trying to showcase the elapsed time and the number of DBUs for a particular job with exactly the same code, everything the same, the only difference being the way they are being triggered. So this is about how you would use system tables for running, for trying to ensure and do the attribution. I mean, there is a lot of information in system.billing.usage. Like for example, let me run a simple code. System.billing.usage, and yeah, that's okay. So the moment I run this, I will have the entire information of my who did what in this. I mean, basically I need to do order by and other things, but essentially you get a whole lot of information from this. And from this, you also can look at each of the jobs, attribution, who did what, when, and what they were doing, and a lot of other information. Like if you see the record IDs, queue names, I mean, this is all purpose as in the notebooks. And if someone adds some custom tags, they will be visible here, or else you will be having a lot of other information like usage metadata and usage quantity and so on and so forth. So this is how you would be working with serverless if you're trying to do any attribution. The system tables and a whole lot of dashboards and other things also are available. Like if I just go to the usage dashboards, this is the usage dashboard, which you can import into a account, and you can choose. There is an option to choose all the workspaces, or you might want to choose a specific workspace. It will list all the DBUs and the number of DBUs for each product line. So this is one way of doing it. The other way of doing it is monitoring, which is what we discussed. Like we run through system.billing.usage table and find the exact attribution of each of those jobs / notebooks / users, etc. All that information directly from the notebook. So that's about this. I just want to quickly showcase one other thing, which is I mean, most of us would like to develop in IDE. I mean, it could be PyCharm, or it could be VS Code, or it could be Cursor. In this case, I have Cursor, and I have probably a simple enough job. In this, I have ingestion task. And that ingestion task, I mean, there is an ingestion task, and there is, I do some analysis in Python, and I do some analysis in SQL. So that's the entire DAG here. Now, you might be using VS Code already, and the way you deploy this job to Databricks is using DABs, Databricks Asset Bundles. Now, DABs is purely YAML based, so you can see a lot of YAML here. Like the job config itself is in YAML, and there is Databricks YAML file also, which you showcase where you want to deploy. In my case, I'm deploying to a specific workspace, and I'm specifying a root path also where I want to push my notebooks. So this is the entire thing. I mean, there is code. There is main.py where I'm trying to loop through and find what is the number of records of a specific table, which I'm passing through, again, job parameters. So I do try to find spark.table and just find the df.count. Yeah, here is where df.count I'm doing. And then there is query, a simple query again, select star. And there is a notebook also, which does a lot of things here. I do ingest some data. So this is the entire thing, and I can deploy directly with this. So I do Databricks bundle sync. If I changed any code, it will reflect in the platform. And also deploy, as in it deploys the code and also runs all of that in a single step. And so this code, whatever I have on my notebook, on my laptop, it's essentially pushing everything into the platform and also running it. So with the bundle run, I'm doing a run of that particular, so it's already available. So I have only one job here, so I will just run that. Now this will start, because I chose, let me go back to my job config. Because I chose performance target as performance optimized, the job will start immediately. to show you the difference between them. So I have create a new job. In this, I can directly jump to performance target. Yeah, performance target. So this is the performance target which we have been talking about. That performance target of performance optimized will trigger the job immediately. Standard mode there will be a startup delay of 4 to 7 minutes. So to go back again, performance target of performance optimized I chose and ran the job. So this is running right now, and if I can copy the URL, I can directly jump to the notebook platform and see where my notebook is, where my job is running. Yeah. So you can see the job is already running. Yeah, you can see 4.57 seconds. A lot of code is there here, but essentially my job is running. Just to show the DAG, this is the DAG. There is an ingestion task and there is analysis task in Python, which is a simple Python script, and there is a SQL notebook again. So this is the complete DAG, and my job is right now running. I mean, my ingestion task is complete, analysis tasks are running, both of them are running in parallel in serverless environment. So this is another way of running your code if you want to use serverless. And the final bit I wanted to show was, if you are used to ADF triggering the pipelines, that's been a bit of a pain because there are lots of new features which are landing in Databricks workflows. For a simple example being, for each recently introduced Power BI task type, a lot of other new features also, run job, for example. So at the same time, ADF orchestration has been lagging a bit. So that's where recently ADF launched a new task type. Let me go to the orchestration. So if I go to Databricks, previously there was notebook, jar, and Python. Now we have job also. So you can create a workflow in Databricks and just use the job ID of that particular job directly in ADF. So for example, in this case, I already created a job. So what you need to do is you just need to create a link service. In this case, I will just test the connection. It should be successful. Once it's done, I will show what I did for this job. Yeah, connection is successful. And here is where I did a job ID. I created jobs here. So let me go to the job. So ADF perf optimized mode and ADF and standard mode. So I have similar jobs here, ADF perform optimized and standard mode. Let me go to performance optimized, and it is one. Let me copy from here. That's better. ADF and perf optimized. It's exactly the same job, and I will run through the job. Okay, what is it? Yeah, I need to test connection. Yeah. And I do have the parameters also already defined here. Just to showcase that I am running the job, let me trigger the run without any trigger right now. So let me trigger the run, and you will see within no time this page getting refreshed. This page should get the same job. It already has come. Yeah, you can see the job already triggered. So this is another way. I mean, if you are more on ADF because of probably the data is somewhere and you need to load the data into ADF Gen 2 probably. I mean, ADLS Gen 2 probably, and you would like to use ADF only as an orchestrator. This is another way of looking at things. Like, you create the workflow with the entire DAG. I mean, right now I only have 2 tasks here, but I could probably create any number of tasks with this number of task types we have. I mean, very recently we added the Power BI, as you can see here, and then there is ABI dashboard and a whole lot of other options also visible here. And the number of tasks right now recently was increased to 1,000. I mean, you can create 1,000 tasks in a single job. So running such a workload through ADF would have been a pain because you would need to each task will go into one pipeline. So each task will run in a single job, the single job cluster. Job cluster needs to shut down, and then again one more new task, new cluster, et cetera, et cetera. All that is a pain. Now, if you move to completely through create the job as a workflow directly in Databricks environment with the UI or with the API or any which way, you create the job, get the job ID, and just put that into the ADF, and you're done. Like this entire the process of reusing clusters and all that will be possible because of this. So that's another way of orchestrating your workflows. So to just briefly run through, we discussed quite a lot. Like these are some of the important advantages of serverless. So the number of things the teams have to spend, or like upgrading DBRs, that's the most important and very painful work. Like the most of the SMEs who are highly skilled, instead of them spending on productionizing use cases, are putting some velocity into the business value, rather they are spending their time on upgrading DBRs. Now with serverless, you don't need to bother about that. And there is a lot of right-sizing the cluster type, clusters, and finding correct instance types, and a lot of other information, a lot of other very, unwanted things probably you would be doing. If you move to serverless, again, that's not going to be a problem. I will run through these three things here. Simple. We saw I don't need to create anything. I just need to select serverless from the dropdown, and we are done. And same with the workflow as well. So business goals, instead of infra and ops, like selecting 1,000 things, you don't need to do that. There is strong cost governance. I have shown how we can do use system tables to create beautiful dashboards to understand who is causing what and how much cost, etc. All the job runs and so on and so forth. And we saw the startup time is very, very fast. We saw in the notebooks, and we saw in the performance mode also, performance optimized mode also. Environment caching, I discussed briefly, like do not use %pip in serverless. Please use environments, which is in the right pane. And we can also use base environments, like that's a complete topic. Probably please join tomorrow's session again. Maintenance free, you don't need to upgrade DBRs, you don't need to upgrade any versions. So Databricks will do the version upgrades behind the scenes, and you didn't need to worry about that. Automatic infra selection. So this is a very important topic. Like you might be choosing, say, some Graviton, for example. You might be choosing Graviton for a specific set of use cases where you would like to use Photon for that workload. Now that is, again, you would have to understand, you need to spend time to understand which workload, is it storage optimized, is it compute optimized, or what exactly is happening, etc. All that, you need to understand your workload and its corresponding instances, instance types, number of instances, and a lot of things. Now, Databricks is doing all that for you. You don't need to worry about that. Rather, you spend time on writing code and just pushing the pipelines to production, etc. One more thing here is automatic infra selection. You might have chosen a specific instance type. For brevity, probably i3. We'll take i3 as an example. You chose i3 as an instance type for your workload. For one fine day, it so happened that there are no i3s available in your particular region. Now, what that entails is you would have to spend time to identifying the nearest family type instance type, which would work for your workloads, and you need to modify it for all your workflows. Now, this is from my experience. I worked with a very big retail and CPG customer from EMEA. I'm based out of London, so from EMEA. And during COVID time, early COVID, the cloud provider said they can't give enough VMs because the VMs are being allocated to very tricky industries. So, tricky and strategic industries, because they are very much required. So at that point, all their workflows did not start because they were using a specific instance type. That instance type is not available. Now, we had to sit and modify each of the workflow to find another instance type and run the pipeline. So that's how painful it was. Now, if you're using serverless, Databricks will do that hard work. And if it so happens that we can't find an instance type which we have been using, we'll automatically fail over to a nearest family instance type automatically for you by us. So you don't need to worry about that. So this is the reason we are saying serverless is auto-optimizing. And as we discussed, If you want to run the pipeline immediately, use performance mode, optimize mode. If not, use standard mode. So there is a lot of other documentation as well. Please look at the docs. So if I go to the release notes, so this is the release notes, which has a lot of information like each of the versions, what it entails. Now performance mode, it landed recently, mid of April, so almost 2 months now. So this is GA now. Roland talked about that as well in session today. Now GA, standard mode is GA. So please take a look at it, and please use serverless, and let us know what you think. That's a brief of what I wanted to discuss in the Practitioner's Guide to Serverless. If you have any questions, I'm available. I will be looking forward to talk to you. Thank you very much.